we've been talking about core Hadoop, which consists of HDFS and MapReduce, but since the project was first started, an awful lot of other software has grown up around it. And that's what we call the Hadoop ecosystem. Some of the software is intended to make it easier to load data into the Hadoop cluster, while lots of it's designed to make Hadoop easier to use. For example, as you'll see in the next lesson, writing MapReduce code isn't completely simple. You need to know a programming language, such as Java, Python, Ruby, or Perl. But there are lots of folks out there who aren't programmers, but can write SQL queries to access data in a traditional relational database system like SQL Server. And of course, lots of business intelligence tools want a way to hook into Hadoop. For that reason, other open source projects have been created to make it easier for people to query their data without knowing how to code. Two key ones are Hive and Pig. Instead of having to write mappers and reducers, in Hive you just write statements like this, which look very much like standard SQL. The Hive interpreter turns the SQL into MapReduce code, which then runs on the cluster. And an alternative is Pig, which allows you to write code to analyze your data in a fairly simple scripting language rather than MapReduce. Again, the code is just turned into MapReduce and run on the cluster. Hive and Pig are great, but they're still running MapReduce jobs, which, as you'll see, can take a reasonable amount of time to run, especially over large amounts of data. So another open source project is called Impala. Impala was developed as a way to query your data with SQL, but which directly accesses the data in HDFS, rather than needing MapReduce. Impala is optimized for low latency queries. In other words, Impala queries run very quickly, typically many times faster than Hive, while Hive is optimized for running long batch processing jobs. Another project used by many people is Scoop. Scoop takes data from a traditional relational database, such as Microsoft SQL Server, and puts it in HDFS as delimited files so it can be processed along with other data on the cluster. Then there's Flume, which ingests data as it's generated by external systems, and again puts it into the cluster. HBase is a real-time database built on top of HDFS. And there's more. Hue is a graphical front end to the cluster. Oozie is a workflow management tool. Mahout is a machine learning library. In fact, there are so many ecosystem projects that making them all talk to one another and work well can be tricky. To make installing and maintaining a cluster like this easier, Cloudera, the company we work for, has put together a distribution of Hadoop called CDH. CDH, or the Cloudera distribution including Apache Hadoop, takes all the key ecosystem projects, along with Hadoop itself, and packages them together so that installation is a really easy process. And the components are all tested together so you can be sure there's no incompatibilities between them. Of course, it's free and open source, just like Hadoop itself. While you could install everything from scratch, it's far easier to use CDH, and that's certainly what we'd recommend. In the next lesson, in fact, you'll be downloading and running a virtual machine which has CDH installed. For more information on the Hadoop ecosystem and how each of these components works, see the instructor notes.